I'm Charles Wang, teacher from the Central High School. Welcome to today's Chem CH12 class. We keep going about the topics acid, base, and salt. Today we focus on those three topics in here. The first one is the acid rain. That's kind of the environmental problems. And then we try to give you more questions about the titration, review of the titration. And finally, we talk about the topics equivalence point. What will happen whenever the chemical reaction reach equivalence point? Hopefully you understand better after this class. And welcome to today's class. What is the acid rain first? We'll talk about a couple topics in here first. We are going to talk about the acid rain. We are going to talk about the indicator later on. And then we'll talk about the pH, pKa, those kind of things. That will bring you to a lot of the calculation. But before we talk about that one, we talk about the acid rain. So whenever we talk about the acid rain, we talk about the hydrolysis because something reacted to the water. They will produce acidic solution. After they did experiments, they found one thing in here, very special things in here. We talk about if you have something in here, the chemical reaction will be like this one in here. I try to write down the equation in here. They found one thing in here. The carbon dioxide in here. I think we need to talk more things in here first before we talk about the acid rain. We have two things we call the metal oxide and the non-metal oxide. Metal oxide, for example, like the MgO, magnesium oxide, or sodium oxide. So whenever we have the MgO2 in here, MgO in here, for example, whenever this one reacted to the water, H2O. They will become the MgOH plus the OH minus 2. Is I missing anything? I hope I didn't missing. I think why do I think that this one cannot be balanced in here? No, I don't think this one is right in here. I saw the one equation can work, but actually they used the two equations. Metal oxide reacted to the water. They can become the Mg2 plus the O2 minus, like this one in here. That's the first thing. That's the first thing. Okay, that's the first thing in here. And alkaline metal ions, or this one is belong to kind of the spectator in this chapter. So your O2 minus reacted to the water become the basic solution in here. So we understand in here, metal oxide reacted to the water, they can produce a basic solution. Then we have another one we call the non-metal oxide. Non-metal oxide. For examples, let's try to write down the equation like this one in here. SO3 plus the water, they will become the H2 and the SO4 or N2O5 plus the water, it will become the 2HNO3. So this one tell you one thing. If we have the non-metal oxide reacted to the water, they can produce acetic solution. Acetic solution. We didn't do anything in here. We just write down the metal oxide reacted to the water, they will produce the basic solution. Non-metal oxide reacted to the water will produce acetic solution. That's it. We don't do anything special in here. Now, the question is very, very clear in here. Non-metal oxide reacted to the water, they can produce acetic solution. Unfortunately, in the air, we have oxygen, nitrogen, we have the water, and we have something we call the carbon dioxide. Carbon dioxide is the non-metal oxide. So in the nature, whenever this one reacted to the water, naturally, this one should produce acetic solution. Remember, that's the nature. Outside in the air, we have the oxygen, we have the carbon dioxide. That's the CO2. We know that we have CO2 in the air. So when it's raining, water coming down from the sky. And then on the same time, the water particles will react to the carbon dioxide. So they give you the equation like this one. Like this one in here. They say for some chemical reaction will be happen like this one. CO2 plus the H2O. They will produce the H3O plus the HCO3 minus in here. They will automatically produce the acetic solution whenever water reacts with the carbon dioxide. So this one tell you one thing. If you go to outside during the raining days, the water come to your head is kind of the acetic solution. It's weak acid. So we say for any pH value smaller than 5.6, whenever it is too much acid, we call the acid rain. If you have a pH smaller than 7, bigger than 5.6, it's the normal raining water. That's the normal. So make sure you understand. Make sure you understand. Whenever your pH smaller than 5.6, we call the acid rain. We call the acid rain. All the others is kind of the normal raining water. That's the first thing. So whenever we have the acid rain, we ask ourselves, which kind of the things will cause the acid rain? And usually found the two things in here. That's the reason why all the global, they try to fix the problems. One is from the automatics, from the automobiles. automobiles, whenever they can do something for the engine, they produce the nitrogen. They produce the nitrogen reacted to the oxygen, and then they can produce pollution. Those kind of things can make the big problems. Another one is from the petroleum. People need the oil from the underground. But whenever you try to refine the oil or refine the petroleum, because inside of the petroleums, it's always come with the sulfur, sulfur. So whenever you try to burning or refining the petroleums, you will automatically produce the sulfur in the air, S. Sulfur is the S. And those things reacted to the oxygen and the water, those things, then will produce problems. If you think about the concept in here, then you understand why people, or the human, or the government, they try to produce kind of the electrical car. Doesn't matter this kind of a car from the battery, or from the hydrogen, or from the others. Because if this one from the battery, we still have the troubles. But if you think about this way, if we can go from the regular gasoline car into the electric car, first one, we solve the automobile problems because they will not produce nitrogen anymore. And then on the same time, we can reduce the usage of the gasoline, reduce the usage from the oil or from the others. Then we can reduce the pollute problems. That's the reason why most of the countries, they try to develop the skills like this. That's the first part for the acid rain. Now we talk about the second part for today's class. We are going to talk about indicator. Like we did the titration. Remember, even for the quiz, we ask you some questions about the titration. The mole ratio must be the same. On the chapter 3, we talk about, for the last topics, we talk about the solubility. How do we know whenever we do the titration? When will we stop? Whenever we see something, some crystal, some solid on the bottom of the container, it's kind of the things like they form the PPT. Then we stop because we understand they reach the end point, or you can say they reach the equilibrium. Then we stop. But whenever we do the titration on the acid or base, how do I know when will I stop? When will I stop? We use something we call the indicator. What's the meaning for indicator? It's kind of the things you understand that they can change the color. Many years ago, I think there's one thing is very cool. Which kind of things is cool? The things, okay? The things I can, okay, use those kind of the sunglasses. I don't know, maybe some people still use this. It's kind of the regular glass. Whenever it's indoors, it's like the regular glass. But whenever it's outside the sunshine, this one becomes the sunglass. They can change the color because of the sunlight. Same thing, there's lots of the things. It's the nature. They can change the color. on different pH value. For example, maybe on the pH equal to the 1 solution, their color is red color. Whenever on the pH equal to the 8, the color becomes the blue. Then you will say, how do I know? No, we didn't know. The people who spend 10 years, 100 years, they try to do the research. They found that those kind of the compounds have those special properties. Their property is in different pH values. They will change the color. We can say is conjugate acid and base have different colors. That's perfect. That's perfect for us. Thanks for those people who give us those information. Will be on the page 7 on here. On the page 7 on here. Okay. We call the acid-base indicators. They tell you those indicators for different range. Remember, not every indicator is a perfect indicator for you. It really depends on which range of the pH value you want to measure. So make sure you understand this one in here. Now, we talk about another thing in here. The indicators. Different indicator for different pH values. So, first one, you try to see which part of your pH will change. Then you choose which indicator you are going to use. Before we talk further, let's talk about the indicator first. That will be on the data page 7, please. On the formula book, you look the page 7, please. We give you a simple examples, just a simple examples. Phenol red. The picture tells you the phenol red is the 6.6 to 8.0. This one is a yellow to red. Okay, in here. This one is the range. The range for this one in here. That's the first thing in here. Phenol red in here. Okay, before we start, let's talk about this one in here. Before we start. Red, yellow, and red. I have a kind of troubles to remember the colors. This one tell you one thing in here. The question is pH range. It means if I use the phenol red, if I drop a little bit of this one in here, just a little bit in here. In the solution, if the pH is more than 6.6, then I will see a yellow color in here, a yellow color in the solution. If for this one, the pH, if the pH is greater than 8.0, I will see red color. I will see red color in the solution. If the solution, the pH between 6.6 to 8.0, then I will see, I believe that's green or orange. Can you tell me? What's the color when you mix the yellow with the red? I think that's the orange. So you will see orange. Okay. So this is what we call the indicator. They try to tell you the pH value range in the solution. Different pH value in the solution. This one will show the different colors. If the pH is more than 6.6, this one will keep the yellow color. This one will keep the yellow color. If the pH on here greater than 8 zeros, then this one will become the red color. Whenever the pH between those two, so this one will form the orange colors. That's the reason why do we use the indicator on the titration. For example, I'm going to show you one simple example in here. If I have like the CH3, COH, something like this one in here. Weak acid. Maybe in the beginning pH equal to around maybe 3.5. Just for examples. Maybe it's not true or whatever, just give you the examples. If I put a phenol ring in here, if I add a phenol ring, then this one will become the yellow color inside, yellow color first. Because the pH smaller than 6.6. This one is the yellow color. Now I try to do the titration. I am going to do one simple thing. I'm going to add the NaOH inside. I'm going to add NaOH. Acid and base, we try to neutralize. So whenever I add a certain amount, I know the concentration for this one. After I add a certain amount, I found the color change from the yellow to red and leave on the orange. Then I stop in here. From the given amount, I drop in here. And the concentration in here. The volume of the solution. Then I can find the concentration of the acetic acid in here. Because I stop in here, it means that they reach the equivalence point or end point. Whenever they reach that point, it means that the mole of the H plus equal to the mole of the OH minus. That is the purpose of the indicator in here during the titration process. Do we use the indicator on the other kind of things? Yes. For example, if I have one solution on here, I have no idea this one belongs to the acid or base. What can I do? I'm going to use the indicator, try it first. First one, I try use the indicator to see this one is acid or base. And then second, I try to find if this one is acid, what will be the pH values. Remember, we have a different kind of indicators. They have a different range for the color change. They have a different range. I tried couple times. So I knew what would be the pH range. on that solution. I cannot get exactly numbers, but I can roughly get that one. After that one, then how do I know what is the concentration on the solution? Then I use the titration to solve the problems. This one gives you the whole concept, what you want to do with each help. For example, I want to find what is the concentration for the solution? I have no idea this solution is acid or base. I use the indicator. We have a lot of the indicator like the litmus paper. You did the experiments. I believe in high school, you always use that. You put the paper in there. If the paper is red color, we understand that this one is acidic solution. If the paper is blue color, we understand that this one is basic solution. That's the first thing. After we know this one is acid or base, then we choose the different indicator. Try it. Remember, on the table, they have all the different indicators. They will change the color on different range. If we understand that this one is a basic solution, we just try some indicators. Whatever, they can change the color on that range. After we found it, that is the indicator we want to use. We understand? For another example, this one is a basic solution. We found the right indicator to use. Then I use the titration. I put the acid inside until the indicator changes the color. Okay, then I can understand the concentration in here. Okay, or you say that if I have no idea about the range, what can I do? Then we have something we call the universal indicator. They will tell you in which range the indicator will change color in different color. So whenever you see that one in there, you know which color to use. Then you will ask, Mr. Wang, why don't we just use that one in the beginning? Answer is very simple, because too expensive. Okay, so that's the reason why they want you to use the simple one first. So we are going to take a break first, and after that we are going to talk about the pH values. We'll take a break first. Okay, let's talk about this one. In here we did those things already. Then we talk about we did the acid rain. Then we talk about the equilibrium points. We talk about the indicator already. So now we talk about something about the Ka, pH, those things in here. First one, please turn to the page 48, please. Page 48 in here, please. Okay. So that's the pH value in here, those kind of things. So they told you a very, very important concept in here. When they reach the transition points, on the page 48, they say that when they reach the transition point, so the pH equal to the pKa in here. They told you in there. The calculation will be on the page 47 in here. So then on the page 48, they told you pKa equal to the pH. Okay, so make sure you understand. They have the Ka equal to the H3O plus concentration in here. Now we try to talk about some calculation in here. Even they try to explain those things to you, but they didn't give you too much calculation parts in here. So we are going to give you some calculation about the pH, those things. First of the first, we try to talk about calculation for the Ka in here first. A very simple example start from here before we do all the calculation about the pH or okay, those things in here. First definition for the H plus concentration, you know that. pH equal to the negative log H plus concentration. Or pOH is the negative log of H minus concentration. For examples, we give to you H plus concentration equal to 2.5 times 10 to the negative 4, just for examples. How do you find the pH? Equal to negative log H plus concentration equal to negative log H plus concentration is 2.5, 10 to negative 4. We got a negative log 2.5 minus log 10 negative 4. Then we try to use the calculator, do certain calculation. Then we got this one in here. Log 2.5. Log 2.5. We got the answer is negative 0.39794. This one plus the 4. I do together equal to like this one in here. Now we talk about the significant figures. From the original concentration, we have the two sig figures, 1 and 2, two sig figures. After we did the log to find the pH, this is the 4 come from the exponential. Nothing to do to the sig figures. The only thing related to the sig figures is on this part. So we try to keep two sig figures. Where is the 3 come from? Come from the exponential form. So this one cannot count for the sig figures. Two sig figures, we only up to here. Answer 3.60. Two sig figures. For the pH values, the whole number do not count for sig figures, only after decimals. So make sure you understand the first thing, because if you make the wrong sig figures, you will deduct the marks. So make sure you understand these parts, okay? So make sure you understand these parts, okay? Second, if you understand this one, then we are going to do a couple questions about weak acid. When they dissolve in the water, we want to see what will be the pH value on the solution. We give you one example in here. For examples. For examples, we have the acetic acid, CH3, COOH, Ka, 1.8. Find the pH. In here. They give you the Ka values for the acetic acid, CH3COH 1.8 times 10 to the negative 5. They ask you what will be the pH value on this one. So we understand CH3COH is kind of the acetic acid. They go to the water, become H plus the CH3 COO minus. The Ka value equal to 1.8 times 10 to the negative 5. Initial 0.500. Because this one is the weak acid, they cannot be 100% ionized in the water. So they only have partially can be ionized. We have the ICE chart again. Initial 0 and 0. Whenever they start to change, we call the minus X plus X plus X. Whenever they finally reach the equilibrium, 0.500 minus X, X and X. Your Ka equal to this one, equal to your H plus times the CH3 COO minus over CH3 COOH. So we got this one in here, 1.8, 10 to the negative 5, equal to X squared over 0.500 minus X. I'm going to show you how do you solve these questions. Later on, you don't need to solve in this way. Cross multiply 0.5 times this one, 9.0 times the 10 to the negative 6 minus 1.8 10 to the negative 5 X equal to X squared. Everything moving to the right. X equal to 2a negative b plus minus b squared minus 4ac. I use the calculator to find the x. Or you can use the calculator to find the x too. After we did the calculation, we try to keep the two sig figures up to here. That's your H plus concentration. We try to find the pH. pH equal to negative log H plus concentration. Equal to we only can keep two sig figures. That's your answer for the pH. Now, the most important part in here is people ask themselves if we try to solve the question like this one, because we talk about weak acid or weak base, whenever they try to dissolve in the water, they cannot be 100%. Then we say that, can we ignore this change? What's the meaning for this? If I can say this one roughly equal to 0.50 zeros. Condition requirements for this one is x must smaller than 0.500 in here. We ask ourselves, if I try this kind of the approximation, what will be my final answer in here? Will this one a big difference or not? So for this one, if we use the approximation, the Ka 1.8 times the 10 to negative 5 approximately equal to x squared over 0.500. So we got the x squared equal to 9.0 times the 10 to the negative 6. I got my x equal to 3.0 10 to the negative 6. That's my approximate values. Compared to this one in here, this is the actual value. How much error in here? The difference is 0.0090135 divided by the correct answer is 3.0090135. So this one is roughly how much error in here? It's kind of 0.3%. It's a very, very small, tiny difference. And usually on chemistry 12, if the error is less than 5%, it's okay. So this one tell you one thing. Whenever we try to find the pH value from here, okay, from here, we use the log these numbers. Sorry, I got the answer is wrong. -3. Sorry, that's my fault. I got this one, the pH value for this one equal to 2.522878745. We only can pick up two sig figures. Answer 2.52 in here. Same number as that one. That's the reason why people like to do the calculation on the acid base for the ICE chart. Because for the acid base, if this one is kind of the weak acid or weak base, if this one is kind of the weak acid or weak base, we always do the approximation in here. We always do this approximation to make the question become simple to solve. Simple to solve. So that's everything I want to show you today. Okay, I want to show you today. Do you have any question in here? So I'm going to here. So that's everything for today.